So in this part of the presentation we are going to look at the second part of 2011. Now we have two matrices here: compute A times B, find a matrix X such that AX equals to B, and find a matrix Y such that AY is equal to A. Right, so I'll just do the first one first. I'll talk about the first one first. So we have A times B. Is that are the dimensions compatible? Something to always check. So this is a 3 by 3, which is to say 3 rows and 3 columns. This is a 3 by 1, 3 rows, 1 column. Are they compatible? Yes, they are, because the number of columns in the first matrix is equal to the number of rows in the second matrix. So that's straightforward enough. What is the output going to look like? More to the point, it is the number of rows in the first matrix times the number of columns in the second matrix. So it's actually going to be a 3 by 1 matrix. Okay, so 3 rows and 1 column. So that's important, because we can sort of set up our answer now. So 3 rows and 1 column. So first row, and we're going to leave little blank spaces after each. So I'm doing the first row of A, and I'm going to leave little blank spaces after each number. I'm gonna do a big summation here. Okay, 2 times something plus 3 times something plus 1 times something, and then the last row, 2 times something plus 1 times something plus 3 times something. And this is matrix multiplication. What are the somethings? The columns from the second matrix. Now in this case there's only one, we're only using the 1 column, and we're only using it once. So we're going to put in, we put in the row, the column values in these places here respectively, in these spots. So this is 2, 4, and 2, 2, 4, and 2, 2, 4, and 2. Now this is a relatively easy matrix calculation. So what is the answer? Let's grab them all up, round them all up. So we have 14, which is 8, 0 plus 8 plus 6 is 14. 2 is 4 plus 12 plus 2. 4 plus 12 plus 2 is 18. 2 plus 4 plus 4 plus 4 plus 6 is 14. So A times B, that is AB there. Okay, the second part, find a matrix X such that AX is equal to B. That is the that comes from the Gaussian elimination part we've done earlier. So this one here, Gaussian elimination. The answer was, if I believe it was correctly, it was 1/2, 1, and 0. If you're not sure where that comes from, you have to watch the other video as well to check that. So A times X is equal to B. I'm not going to check it here, it would just take too long. The last part is this part here. This is the identity matrix. This is actually Y must be the identity matrix. The only thing that would make this work is that Y is the identity matrix I. Now, but just find a matrix. So just to be clear about something, it has to be a 3 by 3 matrix, because A is a 3 by 3 matrix. So you can put in the subscript there that it's a 3 by 3 matrix, and you probably might have be advised to actually just explicitly state it there like that, just on the account of the dimensions being an important matter. So that is that question there. 2011, question 10, Zone B.